Okay, so once again, very good afternoon all. In the last lecture, we have started the case number 3, that is the member or the body subjected to the biaxial stresses along with shear stress. So this condition is not considered as a actually triaxial condition because in the direction of Z there is no any force. So along with sigma x, along with sigma y, this particular member or the body it is also subjected to the shear stress. So in the previous lecture we have discussed all the important concepts related to this case number 3, and then we have discussed about the sign conventions for the shear stresses, and for that purpose we have taken the two important statements. And for considering the sign conventions for the shear stresses, we have taken the major principal plane for our sign conventions. That is, if the shear stress is rotating anti-clockwise, that we have taken positive to the major principal plane, and if the shear stress rotating clockwise direction to the major principal plane, that we have taken negative. Okay, so these are the sign conventions we have used. Then the list of the formulas also I have given, and I think one problem we have solved in the previous lecture, correct? So this problem we have solved in the previous lecture. We have calculated normal, we have calculated tangential stress, and then we have calculated resultant stress on the oblique plane. Okay, so one more problem based on this case number 3 we'll take, and then immediately we'll shift to the graphical method. Okay, so now this is the second problem based on the case number 3, where your member or body subjected to the biaxial stresses, and along with this it is also subjected to the shear stress. Okay, so the statement is in front of you. A machine component subjected to stresses shown in the figure, full stop, find normal, shear and resultant stress on plane inclined at 30 degree with vertical axis. Okay, so the figure is already given to you, and if you see the figure, the member or body subjected to the total 3 types of stresses. So one is the sigma x, which is equal to 300 Newton per mm square. Another is sigma y, again which is equal to 500 Newton per mm square. I have told always sigma x is greater than sigma y, but very less numericals or the problems are there where there is a possibility your sigma y value will be greater than your sigma x. Okay, and along with this sigma x and sigma y, that is normal stresses, these two vertical planes and 2 horizontal planes, that means all the 4 principal planes, they are subjected to the shear stress, and the value of the shear stress is given as a 400 Newton per mm square. And we have to calculate the normal stress, tangential, which is called as the shear, and the resultant stress on inclined plane, and its inclination is given with vertical axis. Total 2 axes असणार आहेत, एक horizontal and एक vertical axis. So vertical axis means the inclination is given with sigma y. Getting हा vertical axis असणार आहे sigma y चा, कुठला हा dotted line indicate केलेला. So this is the vertical axis, and the inclination is given with vertical axis, it is equal to 30 degree. But as we have decided that we have to take that theta value which is in between inclined plane and your major principal plane or vertical plane. So value will remain same. So again here which rule we have to take the theta value which is in between inclined plane and major principal plane or vertical plane. त्यामुळे पहिल्यांदा देताना आपल्याला वर्टिकल ऍक्सिसचा अँगल दिलेला होता, त्याचाच वापर करून आपण तो मेजर प्रिन्सिपल प्लेनशी कन्वर्ट केला. सो मॅग्निट्यूड विल रिमेन सेम, and now your theta is present at this particular corner. So according to that we have to take the sign conventions of the theta also. So here first of all we write down all the given. So sigma x is equal to 300 Newton per mm square. Sigma y is equal to 500 Newton per mm square. We have to take whether both are tensile or compressive. So both are tensile. Then theta is equal to 30 degree. It is correct, but as per the sign conventions, whether that theta will be the positive or negative. Negative. So as per the sign convention, if you see our 4 figures of theta, the figures given for the sign conventions of the theta, according to that we have to take theta is equal to 30 degree. In front of that, by sign conventions. Then tau is equal to, it is equal to 400 Newton per mm square. Okay, but we have to check with major principal plane whether your shear stress is rotating clockwise or anti-clockwise. Their arrow is present at the top side, so it is rotated like this. Getting? Similarly, at another side, it is also rotating like this. So the direction of the rotation is clockwise, and for the clockwise, what we have taken, positive or negative? Negative. So here minus 400 Newton per mm square. So again in front of that, by sign conventions. And we have to calculate sigma n, sigma t, and sigma r. So the process, whatever we have followed for the previous problem, same we have to follow. So put the formula, sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into, what is the formula, into tau into cos theta, or only cos theta? Only cos 2 theta plus tau into sin 2 theta. So put the values, 300 plus 500 divided by 2 plus 300 minus 500 divided by 2 multiply by cos minus 2 into 30 plus tau 400 into sin minus 2 into 30. That means it becomes minus 60. Correct. So if you go for the more and more simplification, so what will be the first answer? 300 plus 500 divided by 2, it is equal to 400. Plus, what will be the next answer? So here I will apply 300 minus 500, it becomes minus 200 divided by 2, means in bracket I will write minus 100 into cos minus 60, correct? Plus 400 into sin minus 60. So like this. So sigma n is equal to. So do the calculations properly. One more step you can write 400 minus, what will be this answer? Minus 100 into cos minus 60. What is this? Minus 100 into cos minus 60. Or you can give this negative sign, or you can transfer that negative sign here. Or if possible, the total calculation, we can go for the simultaneous calculation and you can write down the final answer. But just for step by step calculation, I'm explaining the things in the details. If it is possible to you, you can go for all the calculation part and tell me the answers. So what is this total answer? 696.41 Newton per mm square. Please check your answers, send your answers in the chat box. Sigma n is equal to 696.41 Newton per mm square. Do the calculations properly. So many times here the negative signs are there. So there is a possibility of wrong calculation. Use the proper sign conventions wherever it is required. I've got sigma n 696.41. I've got. Then next, sigma t is equal to sigma x minus sigma y divided by 2. What is the formula? Into sin 2 theta into cos 2 theta. So here once again 300 minus 500 divided by 2 into sine minus 2 into 30 minus tau 400 into cos minus 2 into 30. So here sigma t is equal to minus 100 into sine minus 60 minus 400 into cos minus 60. So you will get the sigma t. Send your answers in the chat box. What is the sigma t value? 286.60 Newton per mm square. You check your answers. Do the calculations of normal and the tangential or the shear stress and check and verify your answers. Hmm. 696.41. Get 9. Get it. How much?
Sir, तिथं minus तुम्ही plus केले 400.
Yes. 400 is the minus actually, no? Here I have forgot to take the sign conventions of 400 also. 400 किती आपलं? Minus in bracket minus you have to write down. Correct. Have considered minus 400? Have considered minus 400? Then you have to consider. Now check it once again. Do the simplified calculation one by one. Go for the simplified calculation. Go for the separate calculation of each term, and then at the end you have to make the addition, subtraction wherever it is required. Correct? So I forgot to take the sign conventions of tau also. So actually it is minus 400. You also take it minus 400 wherever we are keeping the value of tau. That we have to take minus 400. Correct. Answer is correct. 696.41 it is correct. And 286.68 is also correct. Sigma. If they have calculated sigma in wrong, then they also calculate sigma t wrong. Because they have not considered the sign of 400 negative. It's my mistake. Actually, I have not kept that negative sign. So you have done the calculation as per my writing. But you just keep it properly. Minus 400 you have to consider. Have you got the answer? So 3.15 it is incorrect. So Asmita will just once again calculate by keeping the tau minus 400. I forgot to take that negative sign of tau. So do the calculation once again. Have you got the correct answer now? Have you got both sigma and sigma t? Okay, then calculate sigma r also. So sigma r is equal to square root of sigma n square plus sigma t square means 69.41 bracket square plus 286.60 bracket square. 75. Correct. 0.7 Newton per mm. Okay, so this is the sigma r. So do the calculations properly once again if you have made the mistakes, and verify your answers. Sigma n is equal to 696.41, sigma t is equal to 286.60, and sigma r is equal to 753.03. Okay, now it's correct. Sigma n is 696.41, sigma t 286.60, and then resultant will be 753.07. Correct. So take the sign conventions properly for the theta and for the shear stress. If it is positive, if it is negative, take that properly and go for the solution. Okay. So now one more problem we'll take and then we'll move to the graphical method. It is actually totally different. I will dictate the problem. You just write down. Figure I will give. A point in stressed body. A point in stressed body. A point in stressed body. The set of stresses. The set of stresses. The set of stresses on two planes. On two planes. On two planes 45-degree apart shown in figure. On two TWO2 on two planes 45-degree apart shown in figure, full stop. Determine tensile stress acting on. Determine tensile stress acting on plane BC. Determine tensile stress acting on plane BC. Full stop. So figure is given. I will draw that figure. Okay, so this is the plane or this is the figure. So as per the statement, they have given the set of the stresses, whatever the set of the stresses or whatever the number of stresses applied on the figure, it is represented in front of you. That is a member or the body. It is subjected to the total three stresses. That is, one is sigma x, correct? whether sigma y value is given? No. Then shear stress is also given 3 megapascal. Sigma x is given 8 megapascal, and this 2 megapascal is also given on inclined plane. So what is that value? 2 megapascal. So whatever the 2 megapascal is given, what is that value? Sigma n. Why it is not sigma t? Why it is not sigma t? Sigma t is always parallel to the cross sectional area, and normal is always perpendicular to the cross sectional area. What they have asked? Determine the tensile stress acting on plane BC. What is the plane BC? Whether major principal plane or minor principal plane. प्लेन बीसी कुठला आहे? मायनर प्रिन्सिपल प्लेन. करेक्ट. म्हणजे आपल्याला कुठली व्हॅल्यू करायची आहे? सिग्मा वाय. आतापर्यंत आपल्याला काय केलं होतं? सिग्मा एक्स दिला होता, सिग्मा वाय दिला होता, शियर स्ट्रेस दिला होता, आणि आपल्याला काढायचं काय होतं? इन्क्लाइन्ड प्लेन वरचा नॉर्मल आणि टेंजेन्शियल स्ट्रेस. बट नाव हियर इन्क्लाइन्ड प्लेन वरचा एक नॉर्मल स्ट्रेस दिलेला आहे आणि आपल्याला दुसऱ्या एका प्लेन वरचा टेन्साइल स्ट्रेस फाइंड आउट करायचा. करेक्ट. सो नाउ which formula I have to use for my further calculation? By using which formula I can calculate sigma y? By using sigma n formula. So go for the calculation, write down all the given parameter first. Theta is also given. How much? 45 degree. Okay, it is given at the which corner? At point A. As per the sign convention, whether that theta is positive or negative, कारण तो जर theta आपण इकडे रिप्रेझेंट केला कुठे ह्या कॉर्नरला, हा किती येणार आहे? 45 degree. Again here adjacent triangle rule ने जर आपण कन्वर्ट केलं तर तुमचा हा theta काय येणार आहे? पॉझिटिव्ह येणार आहे. So given, write down sigma x is equal to 8 megapascal, which is equal to 8 Newton per mm square. Then tau is equal to how much? 3 megapascal. As per the sign convention, whether this tau will be the positive or negative. For major principal plane, whether it is rotating anti-clockwise or clockwise? Clockwise. We have to take it negative. So minus minus. Then in front of that we can write by sign conventions. Theta is equal to 45 degree. It is also positive by sign conventions, and we have to calculate sigma y. So we are having the sigma n formula for the case number 3, that is sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta plus tau into sin 2 theta. So this is the formula. So sigma n is given how much? Sigma n is, we forgot to write. So sigma n is equal to 2 megapascal, which is equal to 2 Newton per mm square. So here 2 sigma x, we can put the value of sigma x 8 plus sigma y as it is divided by 2 plus sigma x is equal to once again 8 minus sigma y divided by 2 into cos 2 into 45 plus tau ची value negative आहे, so in bracket minus 3 into sin 2 into 45. So keep all the values properly, and one by one you can go for the next step. So sigma n is equal to 2. Sigma x is given 8 plus sigma y divided by 2. Now here 8 minus sigma y into cos 2 into 45 means cos 90. What is the value of cos 90? So here
0.
8 minus sigma y divided by 2 multiply by 0 minus, why I have taken minus here? Because tau is negative. So minus 3 into, what's the value of sine 30? Sorry, sine 90.
1.
Sine 90. 1. So 3 into 1 it becomes 3 into 1 it becomes 1. 3. And this minus sign we have taken because here shear stress is negative. So due to this plus, due to this minus, here you will get the minus. But 3 into 1 it becomes only 3. So here 2 is equal to 8 plus sigma y divided by 2. So 0 into this term it becomes totally 0. Only remaining term minus 3. Now we have to rearrange the terms, like this minus 3 is present at the right side. ते जर मी left side गेलं तर काय होणार आहे? Plus. So 2 plus 3 which is equal to 8 plus sigma y divided by 2. Once again, this 5 into 2 which is equal to 8 plus sigma y. कारण हे 2 राइट साइड ला असणारा डिनॉमिनेटर ला प्रेझेंट आहे. ते जर मी लेफ्ट साइड ला केलं तर काय होणार आहे? ते मल्टिप्लाय होणार आहे. सो 5 into 3. नाउ sigma y is equal to 5 into 2 10 minus 8. So sigma y 2 Newton per mm square. This is the another tensile stress, that is sigma y is equal to 2 Newton per mm square. So only we have to rearrange the terms. We have to take unknown parameter at one side. And for the sigma y calculation, we have taken first 3 at left side, then multiply by 2, then 8 also we have taken to the another side, and you will get the sigma y which is equal to 2 Newton per mm square. Have you got the answers? Yes, those who are attending online have got 2 Newton per mm square. So process is very simple. Instead of calculation of sigma n they have given, and we have to calculate another tensile stress in the form of sigma y. So calculation is very simple. Only thing is that we have to remind the concept, which formula will be suitable for the further calculation. So 2 Newton per mm square, this will be the sigma y value. Yes, have finished. So those who are attending online have finished, have understood. Okay. Now the next graphical method, in bracket Morse circle method. So up till now, whatever the 3 cases we have discussed, this method is called as an analytical method. So analytical means the list of the formulas are given to you, and by using the list of the formulas and by looking to the statement, we have checked whether it is applicable for case number 1, 2, 3, and accordingly we have done the calculation. So up till now, whatever the 3 methods we have used, that is the analytical method. And in the analytical method, only we required the list of the formulas and we have calculated. Now, same parameters we have to calculate, which we have calculated by the analytical. Analytical मध्ये आपण कुठले parameter calculate केले? Sigma n, sigma t, sigma r. Sometimes we can calculate the angle of obliquity also. We can calculate tau max also. Correct? We have not calculated because it is not asked in the statement. But sometimes it is required to be calculated. Now, same parameter we have to calculate by using the graphical method. तेच parameter आपल्याला काढायचे, फक्त कुठली मेथड वापरायची आपल्याला? Graphical method. Here need not require to go for the any calculation. For this purpose we have to read the problem carefully, because in the examination sometimes after the statement in bracket they have mentioned solve this problem by the graphical method, and by mistake we are solving that problem by using analytical method, and you have solved, that's why you will get 1 or 2 marks. तुम्ही जरी ग्राफिकल विचारलं तुम्ही analytical सोडून आला तर तुम्हाला मार्क मिळणार नाही, जरी तुमचे आन्सर बरोबर असतील तरी पण. So we have to read the statement carefully and we have to check whether that problem we have to solve by using the analytical method or by using the graphical method. So this process is very simple as compared to the analytical method. त्याच्यामध्ये कुठलाच फॉर्म्युला आपल्याला रिमाइंड करायची गरज नाही. Only we have to understood the procedure, how to draw the Mohr circle and how to go for the measurement. Okay, so now if you see here there is a one graph in front of you. So for the Mohr circle method, here we have to use the 2 axes. One is x axis and another is the y axis. So if you see, so there is a one horizontal axis that is x axis and another is y axis. So now actually this particular method is mostly applicable for the case number 2 and case number 3. Why? Because in case number 2 and in case number 3 the sigma x sigma y value is given. बघा ह्या ग्राफिकल मेथड मध्ये पण 2 सब टाइप पडतात. त्यामध्ये केस नंबर 2 साठी प्रोसिजर वेगळे आहे, ज्याच्यामध्ये फक्त आणि फक्त आपल्याला सिग्मा x आणि सिग्मा y दिलेला असतो, बरोबर आहे. टाऊ दिलेला आहे का केस नंबर 2 मध्ये? नाही. सो दॅट प्रोसिजर ऑफ दॅट मोर सर्कल मेथड इज डिफरंट. And in case number 3 along with sigma y along with sigma x the shear stress is also given. So the procedure for the case number 3 it is also different. Only small changes there that we'll see while solving the numericals based on this. But you just keep in mind the graphical method is 99% or we can say 100% it is applicable for the case number 2 and case number 3. Why it is not applicable for the case number 2? That we will check after solving one numerical. म्हणजे फक्त केस नंबर मध्ये का ऍप्लिकेबल नाही तर त्याच्यामध्ये फक्त आणि फक्त सिग्मा x ची व्हॅल्यू दिलेली आणि सिग्मा y ची व्हॅल्यू का द्यावी लागते that we will understood after solving one numerical. Okay, now to solve this particular numerical here we have to use the 2 axes. So one is x axis and another is y axis. Okay, so the value of sigma x and sigma y we have to represent on the horizontal axis. The value of sigma x and sigma y we have to represent on the horizontal axis. मग कसं रिप्रेझेंट करायचं? फॉर एक्झाम्पल sigma x is equal to 100 Newton per mm square and sigma y is equal to 50 Newton per mm square. आता ह्या व्हॅल्यू मला ह्या लाईन वर रिप्रेझेंट करायच्या, तर कसं रिप्रेझेंट करणार? तर त्याच्यामध्ये we are selecting one scale that is 1 centimeter is equal to 10 Newton per mm square. Okay, if this scale I will select 1 centimeter is equal to 10 Newton per mm square. मग माझा सिग्मा x किती आला? 1 centimeter is equal to 10 Newton per mm square असेल तर 100 Newton per mm square म्हणजे 10 सेंटीमीटर व्हॅल्यू आली. सिग्मा y किती आला? 5 सेंटीमीटर. बोथ आर पॉझिटिव्ह. मग ते जर पॉझिटिव्ह असतील, हा तुमचा ओरिजिन पॉइंट आहे, बरोबर. ओरिजिन पॉइंटच्या राईट साइडला सगळ्या व्हॅल्यू पॉझिटिव्ह, त्याच्या लेफ्ट साइडला सगळ्या व्हॅल्यू निगेटिव्ह. तसंच ओरिजिनच्या वरच्या बाजूला सगळ्या व्हॅल्यू पॉझिटिव्ह आणि खालच्या. पण ह्या केस नंबर 2 मध्ये शियर स्ट्रेसचा काय इफेक्ट आहे का? त्यामुळे व्हर्टिकल ऍक्सिस मध्ये आपण शियर स्ट्रेस या ठिकाणी रिप्रेझेंटच करू शकत नाही, कारण आपल्याला केस नंबर 2 मध्ये शियर स्ट्रेस येतात का? नाही. That's why we have to represent this sigma x from this origin point as a 10 centimeter and sigma y as a 5 centimeter. And now while looking to the statement we have to check if both values are positive, your maximum Mohr circle will be generated to the right side of the origin. Getting? त्यामुळे नोटबुक मध्ये आता ह्याच्यामध्ये नोटबुक कसं करणार तुम्ही? नोटबुक तुमची हॉरिझॉन्टल करायची, नोटबुक हॉरिझॉन्टल करायची, कारण व्हर्टिकल केलं तर तुमचं ते बसणार नाही. So you have to make your notebook horizontal and we have to check whether both values are positive. Try to take the origin point extreme at the left side, कारण त्या बाजूला तुमची डायग्राम जनरेट होणारच नाही का, तर दोन्ही व्हॅल्यू पॉझिटिव्ह आहे. त्यातली एखादी व्हॅल्यू जर निगेटिव्ह दिली असती कुठली सिग्मा वाय मायनस कारण तो कॉम्प्रेसिव्ह दिलेला असतो मग तो ओरिजिनच्या कुठल्या बाजूला रिप्रेझेंट करावा लागेल म्हणजे ह्या ओरिजिन पासून इकडे 5 सेंटीमीटर म्हणजे तुमची लेफ्ट साइडला पण काही वेळेस फिगर जनरेट होते अशा कंडिशन मध्ये बरोबर तुमचा ओरिजिन हा नोटबुकच्या बरोबर सेंटरला घ्यायचा यू हॅव टू अप्लाय दॅट कन्सेप्ट व्हाईल लुकिंग टू द स्टेटमेंट मग स्टेटमेंट मध्ये बघायचं दोन्ही जर सिग्मा एक्स आणि सिग्मा वाय पॉझिटिव्ह असतील तर तुमचा ओरिजिन जास्तीत जास्त लेफ्ट साइडलाच ठेवा जेणेकरून तुम्हाला राईट साइडला जास्त स्पेस मिळेल डायग्राम ड्रॉ करण्यासाठी जर एखादी व्हॅल्यू निगेटिव्ह दिलेला असेल तर तुमचा ओरिजिन पॉईंट बरोबर तुमच्या नोटबुकच्या सेंटरला घ्या जेणेकरून तुमच्या ओरिजिनच्या लेफ्ट साइडला पण आणि ओरिजिनच्या राईट साइडला पण तुमची फिगर काय होणार जनरेट होणार सो देयर इज वन स्टँडर्ड प्रोसिजर त्या स्टँडर्ड प्रोसेस आय विल टेल while solving the numericals समज सिग्मा एक्स आणि सिग्मा वाय कुठल्या ऍक्सिस वर रिप्रेझेंट करायचे फक्त आणि फक्त एक्स ऍक्सिस वरच गेटिंग आता बघा एक 100 दिला एक 50 दिलाय त्यामुळे 100चा पॉइंट हा थोडा इथे येणार आणि 50चा इथे येणार दोन्ही जर 100 दिले तर एकच पॉइंट मिळणार सो हिअर द ग्राफिकल मेथड विल नॉट बी पॉसिबल टू अप्लाय दोन्ही स्ट्रेसची व्हॅल्यू जर सेम दिलेला असेल तर त्या ठिकाणी आपण मोर सर्कल ड्रॉ करू शकत नाही ही झाली केस नंबर 1 ग्राफिकल मेथड साठी इट इज ऍप्लिकेबल फॉर द बाय ऍक्सियल कंडिशन आता तिसरी केस काय आपली बाय ऍक्सियल विथ शियर स्ट्रेस गेटिंग मग ह्याच्यामध्ये परत सिग्मा एक्स सिग्मा वाय दोन्ही पॉझिटिव्ह असतील तर इकडे रिप्रेझेंट केले आता शियर स्ट्रेस पण आपल्याला देतात आणि आपल्याला शियर स्ट्रेसची साइन कन्व्हेन्शन माहित आहे मेजर प्रिन्सिपल प्लेनला जर तो अँटीक्लॉकवाईज रोटेट होत असेल तर आपण शियर स्ट्रेस काय घेतलेला आहे पॉझिटिव्ह मग तो व्हर्टिकल ऍक्सिस वर पॉझिटिव्ह मध्ये रिप्रेझेंट मग शियर स्ट्रेस जर तुम्हाला फॉर एक्झाम्पल 30 न्यूटन पर एम स्क्वेअर दिलेला असेल तर किती आलं स्केल न 3 सेंटीमीटर मग तो पॉझिटिव्ह रिजन मध्ये रिप्रेझेंट करायचा जर शियर स्ट्रेस निगेटिव्ह असेल तर निगेटिव्ह ह्याच्यामध्ये रिप्रेझेंट नाव ओनली यू अंडरस्टँड द थिंग साइन कन्व्हेन्शन फक्त काय आहे ना तुम्ही अंडरस्टँड करा ह्याच्यावर प्रॉब्लेम सॉल्व्ह केल्याशिवाय तुम्हाला समजणार नाही नाव जस्ट आय एम टेलिंग द इम्पॉर्टंट थिंग्स common rules which are required to be applied before solving such numericals getting so you just understand sigma x sigma y we have to represent on horizontal axis and shear stress we have to represent along vertical axis getting okay so we'll take one problem and then you will get understood or you just have take the heading draw केल्याच्या खाली write down few sentences before solving the numericals I will dictate write down few lines about the important notes while solving problems on graphical method while solving problems on graphical method or Morse circle the tensile and compressive stresses are plotted along horizontal axis in bracket x axis along horizontal axis in bracket x axis the positive stresses are located to the right side of origin and negative stresses are located to the left side of origin. Negative stresses are located to the left side of origin. Full stop. Similarly, the positive and negative shear stresses or positive and negative shear stress, similarly, the positive and negative shear stress will be located above and below the origin, above and below the origin respectively, above and below the origin respectively, along vertical axis in bracket y axis shown in above figure, along vertical axis in bracket y axis shown in above figure. Full stop. So these are the some important things you have to apply by solving the numericals. Okay. Can we take one problem? Maybe 5 to 10 minutes will get extended. Okay, we'll take one problem. So this is the statement. Read the statement carefully. आतापर्यंत आपण तिन्ही केसवरचे प्रॉब्लेम सॉल्व्ह केले, त्याच्यामध्ये कुठंच त्यांनी रिप्रेझेंट केलं नव्हतं की ग्राफिकल मेथडने सॉल्व्ह करा. गेटिंग म्हणजेच आपल्याला ते कुठल्या मेथडने सॉल्व्ह करायचे होते, अनालिटिकल. त्यामुळे अनालिटिकल हा वर्ड ते रिप्रेझेंट करतील ना करतील. जर ग्राफिकल मेथड, मोर सर्कल मेथड असे जर वर्ड त्यांनी स्टेटमेंट मध्ये दिलेला असेल तर तो प्रॉब्लेम आपण फक्त आणि फक्त ग्राफिकल मेथडने सॉल्व्ह करायचा. सो यू हॅव टू रीड द स्टेटमेंट केअरफुली. सो स्टेटमेंट इज इन फ्रंट ऑफ यू. See, a tensile stresses at a point, two perpendicular planes are 100 Newton per mm square and 40 Newton per mm square. They have given the word like tensile stresses. Both are tensile. That means here no any compressive stress will be there. The tensile stresses at a point, two perpendicular planes. दोन प्लेन परपेंडिक्युलर असतात, बरोबर. मेजर प्रिन्सिपल प्लेन आणि मायनर प्रिन्सिपल प्लेन हे एकमेकाला परपेंडिक्युलर असतात. आणि त्याच्यामध्ये मी सांगितलंय पहिली व्हॅल्यू आपण ऑलवेज कुठली कन्सिडर करायची, त्यांनी दिलंय का याच्यामध्ये सिग्मा एक्स कुठला आहे आणि सिग्मा वाय कुठला आहे. सो सिग्मा एक्स व्हॅल्यू विल बी मॅक्सिमम and sigma y will be minimum. So both are tensile. So immediately I can represent on the figure. So sigma x is equal to 100 Newton per mm square. Here also 100 Newton per mm square. Both are tensile. Similarly, sigma y is equal to 40 Newton per mm square. It is equal to 40 Newton per mm square. Full stop. Find graphically. बघा ते वर्ड काय वापरलं त्यांनी, find graphically means here we have to apply the Mohr circle method. याच्या अगोदरच्या प्रॉब्लेम मध्ये फक्त त्यांनी काय विचारलं होतं, find normal and tangential stress. But this graphically word is very very important. Okay, find graphically normal and tangential stress on oblique plane inclined at 30 degree with major principal plane. आपला अँगल कुठल्या शाटला असला पाहिजे, मेजर प्रिन्सिपल प्लेनचा आपला अँगल असायला पाहिजे. पण यांनी सांगितलंय का तुम्ही वरच्या लेफ्ट साइडच्या कॉर्नरला घ्या, तुम्ही राईट साइडच्या कॉर्नरला घ्या, ह्या कॉर्नरला घ्या, त्या कॉर्नरला घ्या, सांगितलंय का नाही. आपण कुठला घेणार, जी व्हॅल्यू थिटा पॉझिटिव्ह इथे त्या कॉर्नरला आपण घेणार. म्हणजे कुठं, पहिलाच कॉर्नर हा लाईक गेटिंग. हा तुमचा कुठला झाला, मेजर प्रिन्सिपल प्लेन. इथल्या मेजर प्रिन्सिपल प्लेन and angle is equal to 30 degree. आणि हा झाला तुमचा oblique plane or inclined plane. Also find resultant stress and angle of obliquity. आणि सगळ्यात शेवटी काय सांगितले बघा, check your answers analytically. म्हणजे ग्राफिकल पण सॉल्व्ह करायचे आणि लिस्ट ऑफ द फॉर्म्युले केस नंबर 2 चे वापरून पण आलेले आन्सर आपल्याला काय करायचे, व्हेरीफाय करायचे. सम लिटल बिट difference is there, maybe 1 Newton per mm square or 0.5 Newton per mm square, but all the answer should be near to that. Okay, so this is the given. First of all, we have to generate the figure like this. Now, draw the figure first. We have to check whether all required values are given. So this is the case number 2 problem because shear stress they have not given. So this is the case number 2 problem. So first of all, write down the given parameters. First of all, write down the given parameters and how to write it, just see. Sigma x is equal to 100 Newton per mm square. In front of that, write down equal. Sigma y is equal to 40 Newton per mm square. In front of that, write down equal. Theta is equal to 30 degree. बघा आतापर्यंत जे जे आपण प्रॉब्लेम बघितले ग्राफिकल अनालिटिकल मेथड तर त्यामध्ये थीटा व्हॅल्यू इज ऑलवेज मेन्शन विथ द 2 थीटा, sin 2 थीटा, cos 2 थीटा. बरोबर. सगळ्या लिस्ट ऑफ फॉर्म्युला जर तुम्ही बघितले सिग्मा n आणि सिग्मा t च्या फॉर्म्युल्यामध्ये फक्त cos थीटा कुठेच नाहीये किंवा फक्त sin थीटा कुठेच नाही. मीन्स दे हॅव टेकन द 2 थीटा व्हॅल्यू फॉर द कॅल्क्युलेशन. सिमिलरली in the graphical method also we have to take the 2 theta value to draw the Mohr circle. So theta is equal to 30 degree. So 2 theta किती येणार? So here theta is equal to 30 means 2 theta is equal to 60 degree. This is very important because in the analytical also we have considered 2 theta. Therefore in the graphical also we have to consider the 2 theta value only. Okay. So these are the given parameters. Now make your notebook horizontal. Both values are positive, so you just leave maximum pace to the right side of the origin. Draw one horizontal axis at the center of your notebook. Draw one horizontal axis. So this is like this. So this is the horizontal axis. I will draw like this. So this is x-axis. This is x-axis. Horizontal बरोबर exactly at the center of your notebook. Your maximum figure will be generated at the right side of the origin. So leave some space at left side also. एकदम कडाला घेऊ नका. Leave some space at the left side also. I have drawn the figure here. Likewise, you also draw y-axis. So this is origin point O. So this is the first step. You have to draw the horizontal axis and vertical axis. We have to select the scale. This scale त्या नोटबुकच्या राइट साइडला लिहायचं वरच्या कॉर्नरला. बघा. Scale 1 centimeter is equal to 10 Newton per mm square. Write down at the top right side corner 1 centimeter is equal to 10 Newton per mm square. So you have to refer all the drawing instruments. अंदाजे काढलं तर तुम्हाला आन्सर मिळणार नाही. जेवढं तुम्ही ह्याच्यामध्ये ॲक्युरेसी मेन्शन करताल तेवढे सगळ्यांचे आन्सर सेम येतील. किटिंग आपण पेन्सिल कुठली वापरतो ह्याच्यावर पण तुमचे आन्सर वेअर होणार आहे त्याच्यामध्ये. If you are using the lead pencil, your answer will be different, maybe by 1 centimeter. If you are using another pencil, maybe your answer will be vary. कारण कुणाला जर ते डिस्टन्स मेजर केले शेवटी तर कुणाला 1.1 मिळेल, कुणाला 1.2 मिळेल. So you have to make the proper accuracy while drawing the figures. Okay, scale is equal to 1 centimeter, which is equal to 10 Newton per mm square. मग 100 Newton per mm square किती येणार आहे सांगा? 10 centimeter. Write down in the given, and here it is equal to 4 centimeter. So sigma x is equal to 10 centimeter, sigma y is equal to 4 centimeter. Write down in the given only. You have to write down the scale also on this particular figure. Okay, now see, we have to represent sigma x and sigma y on the horizontal axis only. Correct? and we know that dimensions. Sigma x is equal to how much? 100 Newton per mm square. But as per the scale, it is equal to. So from this particular origin point, take 10 centimeter to the right side of the origin. Take 10 centimeter to the right side of the origin. त्या origin point पासून 10 सेंटीमीटर वर एक पॉइंट घ्या and represent this as a point A. From the right side of the origin, locate the position of sigma x as a 10 centimeter आणि खालच्या बाजूला सगळ्यात बाजूला बघा त्या origin पासून एक horizontal line A पर्यंत ड्रॉ करा एकदम खालच्या बाजूला आणि त्या ह्याला दोन arrow द्या आणि त्याच्यामध्ये sigma x is equal to 100 Newton per mm square which is equal to 10 centimeter. आपल्याला समजलं पाहिजे ना पॉइंट ए म्हणजे काय इंडिकेट करतोय. So take 10 centimeter to the right side of the origin as a point A. Represent their dimensions exactly at the bottom side. कारण मध्ये जर काढला तर आपल्या फिगर मध्ये येईल सगळं. Then sigma y also we have to represent on the same axis. बरोबर आहे? It is also positive. मग तो कुठे रिप्रेझेंट केला पाहिजे? Originच्या right side ला. But what is our distance? 4 centimeters. So similarly, from origin point O, represent one more point, that is point B. Point B. How much distance? 4 centimeter. So this is sigma y is equal to 40 Newton per mm square, which is equal to 4 centimeter. So represent their dimension also from the origin point. So we got 2 points, point A and point B. Point A means position of sigma x and point B means position of sigma y. So what is the distance between point A and B? Measure it. What is the distance between point A and B? 6 centimeter. Yes. Those who are attending online have located the point A and B.
Yes, sir.
Okay.
Yes.
So the distance between A and B is the 6 centimeters. What is the center of AB? 3 centimeters. So take one more point in between A and B as a point C, as a center of AB. Locate the point C exactly at the center of AB. म्हणजे BC किती झालं 3 सेंटीमीटर आणि AC किती झालं 3 सेंटीमीटर. So here only we have to take the center of AB. Getting? We have to locate the point C as the center of AB. Then take radius CB or CA and from point C or by selecting the center point C, draw one circle which is passes through the point A and B. Point C ला center point select करा. किती रेडियस घ्या पॉइंट C पासून? एकतर B पर्यंत किंवा A पर्यंत. दोन्ही रेडियस सेमच आहे आणि त्या पॉइंट C चा सेंटर उपयोग करून त्या B आणि A मधून जाणारा एक सर्कल ड्रॉ करा. Like this. By selecting the center point C, draw one circle which is passes through the point B and A. जरी तुम्ही B पर्यंत डिस्टन्स सिलेक्ट केलं तर ते सर्कल ऑटोमॅटिक पॉइंट A मध्ये पण जाते कारण दोन्ही रेडियस सेम आहेत. गेटिंग? अंडरस्टूड द प्रोसिजर. पहिल्यांदा A पॉइंट रिप्रेझेंट केला, परत पॉइंट B रिप्रेझेंट केला, परत C रिप्रेझेंट केला, त्यानंतर C ला सेंटर सिलेक्ट करून पॉइंट B आणि A मधून जाणारा सर्कल ड्रॉ केलं. करेक्ट? Okay. Now we have to represent the 2 theta angle. We have to represent the 2 theta angle. आता ह्या पॉइंट C पासून आपल्याला 2 theta angle ह्या पॉझिटिव्ह रिजन मध्ये रिप्रेझेंट करायचा आहे बाय सिलेक्टिंग दिस रेफरन्स लाईन ऍज अ हॉरिझॉन्टल लाईन. बरोबर आहे? आता अँगल मेजर करण्यासाठी तुम्ही काय वापरताय? अँगल हे करण्यासाठी प्रोट्रॅक्टर, बरोबर. बाय कीपिंग दिस ऍट पॉइंट सी, कीप युअर प्रोट्रॅक्टर ऍट पॉइंट सी अँड समजलं का कसं केलं. पॉइंट सी पासून पॉइंट सी ला तुमचा प्रोट्रॅक्टर ठेवा, बरोबर. आणला नाही. एनीबडी हॅविंग प्रोट्रॅक्टर डबल आहे का कोणाकडे? आहे का डबल कोणाकडे? कुणाकडेच नाही तिकडे, पण कुणाकडेच नाही. रेडियस घेऊन हा हा येस, इट इज ऑल्सो कमिंग. पॉइंट सी ए एवढी रेडियस घेतली, ठीक आहे. तर पॉइंट सी ला ठेवून एक आर्क मारा आणि तसंच पॉइंट ए वर ठेवून आर्क मारा. दोन्ही आर्क एकमेकांच्या कॉन्टॅक्ट मध्ये येतील, एक तुम्हाला पॉइंट मिळेल. बट दिस इज ऍक्च्युअली द मोर सर्कल मेथड, त्यामुळे त्याच्यामध्ये सर्कल दिसलं पाहिजे. By selecting point C and by using the protractor, you have to represent the angle 2 theta in anti-clockwise direction. म्हणजे C to A ही आपली रेफरन्स लाईन झाली, बरोबर. त्या रेफरन्स लाईन पासून अँटी क्लॉकवाईज डायरेक्शन मध्ये 2 थीटा अँगल रिप्रेझेंट करा आणि त्याच्यामुळे तुम्हाला एक नवीन पॉइंट मिळतोय सर्कलवर. कुठला? पॉइंट डी. रिप्रेझेंट दॅट पॉइंट डी. रिप्रेझेंट पॉइंट डी येते. रिप्रेझेंट पॉइंट डी as a 2 theta. Represent point D as a 2 theta in anti-clockwise direction, and from point D draw one vertical line in the bottom direction. From point D draw one vertical dotted line, exactly vertical dotted line in the downward direction. तर ती लाईन तुमच्या कुठल्या तर एका ऍक्सिस वर येऊन कॉन्टॅक्ट मध्ये येईल, बरोबर. खाली जर आपण लाईन ड्रॉ केली पॉइंट डी पासून, तर तुमच्या त्या एक्स ऍक्सिस वर तो पॉइंट येईल. अँड गिव नेम टू दिस पर्टिक्युलर पॉइंट ऍज अ पॉइंट ई. फ्रॉम पॉइंट डी draw one vertical line in a downward direction. It is in dotted condition, so you will get one more point in between C to A. C आणि A च्या मध्ये तुम्हाला पॉइंट मिळते, त्या पॉइंटला नाव द्या कॅपिटल ई. Finish? So those who are attending online, have you finished? Have you drawn it?
Yes, sir.
Yes, sir.
Okay. Now see. Now see. From point O. From point O. Draw one dotted line and join the distance OD. OD कुठे आहे? सर्कल वरचा पॉइंट डी आणि आपला ओरिजिन हे दोन्ही पॉइंट डॉटेड लाईन नी जॉईन करा. ड्रॉ द ओडी डिस्टन्स बाय द डॉटेड लाईन. ड्रॉ द ओडी डिस्टन्स बाय द डॉटेड लाईन. फिनिश. Draw the OD distance by the dotted line. Now your process is over. Your more circle is over. Now we have to calculate our unknown parameter. आता बघा, unknown parameter calculate करताना आपल्याला कुठले काढायचे आहेत? सिग्मा n, सिग्मा t, सिग्मा r and angle of obliquity. मग हे 4 डायमेन्शन काढण्यासाठी आपल्याला कुठले डायमेन्शन मेजर करायचे? तर फर्स्ट वन, फ्रॉम पॉइंट O to E. From point O to E, draw one horizontal line. तसं आपण सिग्मा x आणि सिग्मा y रिप्रेझेंट केलाय, तसं from point O to E. This is your sigma n value. From point O to E, but your OE distance is there on the figure. That is your sigma n. How much? 8 point. Now you just represent on the figure. Afterwards, I will do the measurement. मी जसं मी फिगर मध्ये दाखवले सिग्मा इन म्हणजे कुठलं डिस्टन्स आहे O to E. Similarly, D to E म्हणजे वर्टिकल करेक्ट. DE distance will be your sigma T. DE distance from point D to E, this is your sigma T. Sigma T as a DE. After that, OD, जे आपण dotted line indicate केले OD, correct? OD will be represented by dotted line, so that distance will be your sigma R. This distance will be your sigma R. फक्त फिगर वर हे काढा अगोदर कुठला सिग्मा n आहे, कुठला सिग्मा t आणि कुठला सिग्मा r आहे. So O to E distance will be sigma n, D to E distance will be sigma t, and O to D distance will be sigma r. And angle DOE, बघा पहिला पॉइंट कुठला सांगितलं मी, अँगल D, then O and E. हा अँगल जर तुम्ही मेजर केला एवढा, तर दिस इज युअर अँगल ऑफ ऑब्लिक्विटी, दॅट इज फाय. अँगल DOE, this is your angle of obliquity phi. While solving the numericals, represent the position of sigma n, sigma t and sigma r for each and every numerical. ते आपल्याला फिगर मध्ये समजतंय की सिग्मा n म्हणजे कुठलं डिस्टन्स आहे, सिग्मा t म्हणजे कुठलं डिस्टन्स आहे आणि सिग्मा r म्हणजे कुठलं डिस्टन्स आहे. Have you located all the four unknown parameters on the figure? Sigma n, sigma t, sigma r and phi. Okay, now this is your Mohr circle over. पण आपल्याला मिळाले का फायनल आन्सर इन द फॉर्म ऑफ न्यूटन पर mm स्क्वेअर. सिग्मा n आपण एनालिटिकल मेथड मध्ये आपण न्यूटन पर mm स्क्वेअर मध्ये काढला होता, पण आपल्याला मिळालंय का सध्या नाही. नाउ बाय युजिंग द स्केल, नाउ यू हॅव टू गो फॉर द कॅल्क्युलेशन. आता आपल्याला कॅल्क्युलेट करायचं, त्यामुळे नवीन पेजवर फ्रॉम figure like this, from figure 1 centimeter is equal to 10 Newton per mm square. हे आपण स्केल कन्सिडर केलेलं, बरोबर आहे. पहिला पॅरामीटर आपल्याला कुठला काढायचा आहे, सिग्मा n. ओके, सो नंबर 1, सिग्मा n इज इक्वल टू कुठला डिस्टन्स आहे, सिग्मा n म्हणजे कुठला डिस्टन्स आहे,
O to E.
सो OE into scale. Sigma n is equal to OE into scale. Now measure OE distance from your respective figure. Okay, one answer is 8.5. Any another answer? 8.6, 8.5, 8.6. Whatever answer you got, that you have to write. So this is the graphical method. So many instrumental errors are there. So many manual errors are there. बरोबर आहे, म्हणून मी सांगितलं लीड पेन्सिल वापरताय का साधी पेन्सिल वापरताय, त्याच्यावर तुमचं ते 1 सेंटीमीटर व्हॅरी झालं. सो व्हॉट एव्हर द डिस्टन्स यू गॉट, पण ते 8.10 नसलं पाहिजे किंवा ते 8 पॉइंट लेस 2 mm नसलं पाहिजे. इट शुड बी नियर अबाउट दॅट. सो व्हॉट एव्हर द डिस्टन्स यू गॉट, सो सपोज आय विल राईट 8.5 into 1 सेंटीमीटर इज इक्वल टू 10 न्यूटन पर mm स्क्वेअर. तर 8.5 ला कितीने मल्टिप्लाय करावं लागेल, 8.5 into 10, how much, 85 Newton per mm square. This is your sigma n. Second, sigma t. What is your distance for the sigma t from the figure, DE.
2.5.
So DE into scale, DE into scale. Now what is your DE answer? 2.6, 2.7. Any another answer?
2.5.
2.5. So here position of angle plays very important role. तुम्ही किती accurate घेता angle त्याच्यानुसार तुमचे distance फक्त vary होते. So I will take 2.6. ज्याचे कुणाचं 2.5 आले, ज्याचे कुणाचं 2.7 आले, that you have to represent. So 2.6 into 10, which is equal to 26 Newton per mm square. Then third one, sigma r, which distance? Sigma r साठी कुठलं distance measure करायचे? OD. So OD into scale. How much distance is there? OD
8.9.
8 point. Okay, 8.8, 8.9. Any another answer? 8.7. Yet 9. It's your errors. Whatever you have drawn, it is your errors. So there may be chances due to that you have not used that protractor, correct? You have not used the protractor, so your answer may be variable. So it is near about, just I will check. Some of you got the 8.9 or 9. Maximum 8.9 or 9. 8.8, there is a very less chances to get the 8.8. Otherwise 8.5 it is also correct. 2.6 it is also correct. 8.9 or 9, this is OD distance. I will take 9. So 9 into 10 is equal to 90 Newton per mm square. And the fourth one, what is our fourth one? Phi is equal to which angle we have to measure? Angle DO. कुठला जरी पॉइंट घेतला तर चालते बघा. E च्या अगोदर पॉइंट B पण आहे, C पण आहे, A पण आहे. We'll take E, angle DOE. Now measure the angle. आता हा angle measure करण्यासाठी मात्र तुम्हाला protractor लागणार आहे. I will give the answer. Those who have got the answer, are you able to send what is angle DOE? Can you measure? Those who are attending online, if it is possible to you, please measure the angle and tell me. No. $17. Correct. 17 is the angle of obliquity. Please check your answer. So tomorrow you just come with that protractor and once again you measure the angle, or you can measure it at your home whether it is coming 17 or 18 like that. So this is the graphical method. Understood the procedure? Now all these answers we have to verify with your analytical method. आता ह्याच्यामध्ये तुम्हाला फॉर्म्युला माहिती आहे रिझल्टंटचा फॉर्म्युला माहिती आहे काय? स्क्वेअर रूट ऑफ सिग्मा एन स्क्वेअर प्लस सिग्मा एन स्क्वेअर प्लस सिग्मा टी स्क्वेअर. त्याचा आन्सर किती येते रिझल्टंटचं बघा. $85 स्क्वेअर प्लस 26 स्क्वेअर आणि परत त्याचा स्क्वेअर रूट 88.88. and your what is your sigma by using the graphical method? 89. म्हणजे नियर अबाउट तुमचं 88.8 म्हणजे 89 झालं. 88 means your answer is near to your graphical answers. आता ह्याच्यामध्ये accurate मिळेल काही जणांना मिळणार नाही. याचा अर्थ असा नाही की ते आपलं चुकलं. Because here there are so many instrumental errors, there are so many manual errors. Like that you have to verify the answer. म्हणजे फक्त तुम्हाला सिग्मा एन आणि सिग्मा टी हे पण आपले बरोबर आहेत का नाही तर ते कुठल्या फॉर्म्युला पासून आपण चेक केले तर रिझल्ट. म्हणजे बाकीचे कॅल्क्युलेशन करायची जास्त गरज आहे का? पण लक्षात ठेवा व्हेरीफाय युअर आन्सर्स अनालिटिकली. ह्याचा अर्थ असा की तो प्रॉब्लेम तुम्हाला अनालिटिकलनं पण सॉल्व्ह करायचा. Getting? For some problems they are not mentioning, for some problems they are mentioning. जिथं मेन्शन केले तिथं सॉल्व्ह करा, जिथं मेन्शन केलं नाही तिथं स्वतःचं कॅल्क्युलेशन करायला जाऊ नका. कारण म्हणजे ग्राफिकलचे आन्सर त्यावेळी वेगळे येणार, अनालिटिकलचे आन्सर वेगळे येणार. तुम्ही काय तर दुसरंच लिहून येणार, प्रॉब्लेमला 0 मार्क. Getting? Understood the procedure? पहिल्यांदा पॉइंट ए रिप्रेझेंट केला, परत पॉइंट बी रिप्रेझेंट केला, त्याचा सेंटर पॉइंट सी घेतला, सी पासून सर्कल ड्रॉ केलं, परत त्याच सी पॉइंट मधून 2 θ अँगल रिप्रेझेंट केला, पॉइंट डी मिळाला, डी पासून व्हर्टिकल लाईन ई काढली म्हणजे ई पॉइंट मिळाला आणि सगळे अननोन पॅरामीटर फिगर वर 100% रिप्रेझेंट करायचेच. सिग्मा एन म्हणजे कुठला आहे, सिग्मा टी कुठला आहे, सिग्मा आर कुठला आहे आणि फाय कुठला आहे. And at the end, from figure, you have to do the calculation like this. Sigma n OE into scale like this. Understood the procedure? Any problem? Getting again some problems are there that we will take in the next lecture. Okay. So those who are attending online, have understood the procedure?
Yes, sir.
Any problem? Anybody is having any problem? You can ask. Have you understood, everyone? It is very simple. Homework. Everyone have understood? Okay, great. Okay, with this today we will stop here. One homework I will give you. I will send that homework problem on your WhatsApp group. Accordingly, you can solve at your home. Okay, with this today we will stop. Next lecture will take some variety problems.